A very good afternoon to one and all. Yes, can anyone give a raise of hand to show that my voice is audible to you all? Yes. Thank you so much. You can kindly lower your hands. Students, you can lower your hands, no problem. Yeah, thank you. Okay, so welcome to day two workshop. The timings had been a bit delayed because there was a bit of delay in the given other batches. So that's the reason there was a few of delay over here. Okay, Swarup, is this a hand of raise for doubt or is it by mistake? Okay, cool. So I'm Sam. So as I was present in the day one workshop, I'm gonna be taking this day two workshop. So as I said in the beginning, or as I said in the earlier classes, I assume that you all have finished your assignment, right? There was an assignment given to you. So can I see a raise of hands if you have completed with that assignment? It was an assignment based on servo motor. Okay, I see 35 attendees and three of you have completed and okay, five of you have completed, six, seven, okay. Thank you guys. You can kindly lower your hands. Students, may I know why is this the less response in completion of that assignment? I mean, did you face any error or you just didn't want to do that assignment? It's okay. See, it's all right to be frank. There's no issues in that. You can just tell us if, you know, if you wanted to do that assignment or if you don't want to do that assignment, because I will be giving a few explanation based on those assignments. So if you have completed it, you would have, got it. So please do tell me if you're not completed it so that I can give an explanation so that at least you would have a knowledge of that assignment. So can I see raise of hands if you have not completed that assignment or if you are yet to do the assignment? Hmm. So it means I can just skip it. Okay, fine. Okay, let me just bring that later. So in day one, you were taught about LED in module one. Okay, in module one, you were taught about LEDs. So I will request students to go to your chat box and tell me how do you identify the positive and the negative side of an LED? How do you identify the positive pin and the negative pin? How do you know that where do we have to, give this link to? So can you just drop a text telling which pin will be termed as negative and which pin will be termed as positive? You can type it in the chat box and I will wait for a while so that I can see few responses and then go ahead. Bent pin named as negative. Okay. Okay, so Swarup, you are telling me that bent pin name is as negative. Okay. Anyone else wanna go with Swarup or telling him that if he's wrong or not? Okay, students, see, let me remind you again, this workshop is to give some knowledge to you. So unless and until I see an interactive class, I won't be able to end the class, nor will I be able to move forward. So, okay, now Kiran Reddy is telling me that bent pen is positive. Okay, fine. Let me go with these things. Okay, how many of you feel that Swarup is telling the right thing, that bent named pin is a negative? Can I see a raise of fan so that towards Swarup if that pin is negative? Okay. So how many of you feel that Kiran Reddy is correct? I mean, a statement is provided, bent pin is positive. So can I see a number or rise of hands if he is right? Okay, one, two, three, Okay, then yes. Okay, Sayyid. Yeah. Thank you guys. Students, you can kindly lower your hands. Yeah. Saurabh, I wanted to go check on the LED pins. Okay. See, on these LED pins, there is something known as cathode and anode. Okay. Always remember that cathode and anode. Okay. The bent pin will be positive at any cost. Okay, a bend in the pin or a dentist pin will be the positive pin, and a pin with the longer length or a straight structure will be known as the negative. Okay, see, you may seem why am I stressing you guys on this very basics is trust me, if you are attending an interview or if you are been asked by professor, the very basics is the ones they go after. Okay, they don't just jump into complicated parts. Okay, they just go with the very basics and then move ahead. Okay, that's the reason I'm just not trying to stress you on this. So make sure that you're well versed in these topics. Okay, and consider day two, module three. That will be based on module one. So that's the reason I'm asking you a few questions on that. Swarup, I guess you have acknowledged this thing. So if you have understood this, please give a rise of hand. Or if you still think that you're right and I'm wrong, do chat. Okay, Swarup. Thank you. Okay, then let's move forward. So, as I said, yes, Swarup. Okay, do you want me to unmute you? Okay. Yes, Swarup. You can unmute yourself. All right.
Nothing, sir.
Okay. Yeah. Okay, Swarup. Fine. So before I jump into day two, as I said, there was an assignment given to you all, right? Let me see because as I said, when people to raise your hands when you had, if you had completed the assignment, I saw very little hands. So let me just give you an example. Okay, why did I even give that as an exam, an assignment? Okay, okay, I have to share my screen. Just a second. So yeah, so why did I give that as an assignment? Why was it not taught in the class? Is simple because that application is easy, and that application is well versed. Okay, it has been used. There's a worldwide robotics thing. So that's the reason I gave that to be your own work. So yeah, can anyone give a raise of hand to tell me if my screen is visible to you? Yeah, thank you. Cool. You can kindly lower your hand, students. All right. So day two of workshop. So as I said before, the day two, you were given an assignment. Just a second. Yeah. So if I'm not wrong, this was the assignment given to you. Server control. Okay. So as I said, you can see there is an attached work module on this. Okay, it is in white. Okay, so what is this? This is a fin. Okay, this is a fin in the servo motor. And why have I given you the servo motor and no other motor? Okay, there's a different type of motors as well. And yeah, let me say this. Well, if you were kids and if you had remote control cars, a toy car, okay, let it be in such a manner. So if you had a remote control toy car, and if you were naughty as such as me, or let's just say if you were just interesting to see what is inside this part, and you just broke it apart and just started taking wheels and stuff, you would have found a motor in it. Okay, that motor is what we call it as a PWM motor. Okay, so now that PWM motor will have only two ways of running, clockwise and anti-clockwise. And to observe that anti-clockwise or clockwise running of that motor is difficult even in the given virtual scenario. Okay, so that's the reason we stick with this servo motor. So why servo motor, sir? Why why have we keep stressing on this servo motor? Why was it given as assignment? Now servo motor has a very good application domain. Okay, this servo motors are very much applied in a robotic arms. When you want to move the arms, right, this servo motor has been used over there. Okay, this servo motor has also been used in the hip rotation of robotics. Okay, so it is also used in locking and unlocking systems. Okay, So this is the application domain of the servo motor. So why did I make you to do it on your own? Simple. The more you learn on your own, the more it will be sticking with you for the lifelong. Okay. So if you can see in the code, it is ash include servo.h. So it is a must that when you use a servo motor, you should use a servo library called as servo.h. Okay, the header file. Why? Because servo has a few other topics such as attach and write. Okay, it is not digital write or digital attach. Okay, so that's the reason. Okay, let me just get it done. So that's the reason why it has been over there. Okay. Now you can see the next step is a server Vikasana. Why it is server Vikasana? Vikasana is nothing but a alias name. So you can give it any other name you wish to. Okay. Whenever you call Vikasana, you are indirectly calling server. Okay, you're calling server without calling it name. So that's the reason we are giving it an alias name. And let me just jump to voice setup Vikasana.attach 3. So you're attaching pin number 3 because as you can see over here, this pin, okay, this pin has been taken as the output pin, okay, and it is going to get attached to server, and you're calling Vikasana. So indirectly you're just calling what? You're just calling server. So getting attached to it, and then you're writing 0, 90, 180. So if you had done the simulation part, you would understand what is 0, 90, 180. If not, okay, you see this 0 degree, okay, 0 is nothing but 0 degree, and it has a limitation of 0 to 180 degree. Okay, and please do bear with my writings because this is as far as good as I can get in the mouse and a whiteboard. So yeah, so it has a limitations of 0 to 180 degree. Okay, so that's the reason why I have given it 0, 90 and 180. Okay, you can give any values from 0 to 180, but I was just stuck with 0, 90 and 180. And the delay functions as I said, it is to give a pause so that a human eye can observe it. So why are we given a delay after 180? See, void loop, okay, it will be running infinite number of times. Okay, so it will be running infinite number of time. So after 180, it will be jumping to 0. Okay, and if there's no delay, you will not be able to observe this 180 degree angle. So that's the reason I've also given a delay after 180. So it will stay in 180 for such a long period of time, which is 1.5 seconds approximate, and then again it will jump to 0. Okay, so that's the reason. And so why it is limited to 0 to 180 degrees? See, as in a human hand or in a human body, you can rotate or you can simulate 0 to 180 degree, not more than that. And robots are a vision, or it is admired by a human. Okay, so they make the robot in the form of a human. Okay, so a robot will also be able to do 0 to 180 degree unless and until it is something else or if it is a special kind of a robot. Okay, so that's the reason. So I presume that you have all agreeing with this and you have no more doubts. So if you have no more doubts, please give a rise of hand so that I can move ahead with day 2 workshop. Yes. Students, yes, as you can see, there are 37 attendees and I would require a minimum rise of hands to move ahead. So yes, so there's 5, 6, 8, 9 out of 37. One more and I'll be able to move ahead. Yes, thank you students. You can kindly lower hands. Okay, let me just move forward. So now day 2. So what I'm going to do in day 2? Day 2, I'm going to teach you about model 3. Okay, so model 3 will be consisting of LEDs, but as well as LEDs, I've added another component. Okay, so this component will be known as push button. Okay, so what is push button? So if you are in the field of electronics, you would know, but if you don't know, okay, no problem. Let me give a small definition. See, these push buttons are used in every given circuit. Okay, this is more like a reset button. Okay, or if this is more like an manual switch off or an emergency button. Okay, fire. These comes under this push buttons. Okay, let me just divide this. Okay, so as you see over here, this on the very right hand is the design part. Okay, this is how it appears, and on the left hand, okay, this is how the work module, okay, behind the work module is appearing as. Okay, so that is why I have chosen this push button and the working module, so that I can give you the working ideology. Okay, so now see, as over here, this is 1B and 1A. Okay, and over here 2B and 2A, and that's it, nothing much. And over here, see, this is the button. Cool. So this is the design part. Now let me jump towards the backend working ideology. So 1A, okay, see, you can see that 1A and 1B has been connected. Okay, so what do you mean by this? Okay, let me say that I'm going to give a supply of 5 volts. Okay, and as I said previous, please do stick with my, bear with my editing, because it is a mouse and a board. Okay, so 1A, I'm going to supply it with 5 volts. So when I supply this with 5 volts, if I'm going to take the charge from 1B, it will also be of 5 volts. Okay, so that is the meaning of that it has been connected, or it has been short. Okay, as the same applies for 2B. If this is 0, so well as 2A will be 0. Okay, so that's there. Now if you can see, observe out over here, see, this is what is known as flip-flop. Well, I can teach you what is flip-flop, but that will be too complex at this very stage. So let me just say this is a gate. Okay, now see, you're seeing a button over here, right? This button. So this button is nothing but when I apply pressure over here, okay, and I keep on applying a pressure over there, this gate will get connected to this. Okay, and then when I take a reading into A, okay, this will be changed to 5 volts. Okay, this reading will be changed to 5 volts. How? So see, this 1A, 1B, okay, this, okay. So when I push a button, the circuit will be in such a way that it will get crisscrossed. So this will come over here. Okay, so this value will be crisscrossed to the very end of the diagonal, which is 2A. Understood? So that's the reason this is there. And once I remove the pressure from this button, okay, if I remove the pressure from this button, the gate will be disconnected. Okay, and the value of 2A will return to A. Okay, and there's a defined definition given over here. A device designed to close or open a circuit on a, open an electric circuit when a button or a knob is pressed, and to return to a normal position when it is released. So as I said, if I apply a pressure and keep it under a pressed impression, it will be connected, and if I release it, if I take out the force, it will be disconnected, and it will return to the first stage where it was disconnected. Okay, so that is what push button is right over here. So students, if you have any more doubts or if you need more clarification, please give a raise of hand, or you can even drop a text in the chat box. Okay, very well. Can I see a number of hands to see if your Tinkercad account has been logged in and signed and is up and running? Six. So see, I guess you can see my screen. So you see there are almost 40, okay, 39, and I will require a minimum so that I can move ahead. All right. I see 8 raise of hands, 2 more, and you can go ahead. 1 more. Yes, thank you, students. You can kindly lower your hands, and let us just jump into our Tinkercad account. Okay. All right. I guess this is going to take a bit of long time. Okay. In the meanwhile, okay, let me just come back to you. Okay. You remember that? Okay. Kiran Reddy, is this a rise of doubt, or was it not lowered? Okay, cool. So see, you remember I said when you come for the day 2 workshop, I'll have a surprise for you. Well, this surprise is nothing but, well, we from Team Vikasana are gonna give you a predefined stage. Okay, so what is this stage gonna do for you? Well, it will give you all the spotlight you require. Understood? So how do you want to get the spotlight? Simple. So what is to be given? Well, you have to give me an ideology. Okay, it is an idea submission, and this idea can be based on business, agriculture, fashion, any of the world given scenarios. Okay, aspects, you can be any number of it, but your ideology should be an alternative method. It should be a better method given the current scenario. Okay, so come up with an ideology. Okay, and when you want to submit it, you have to submit it in a form of document. Okay, doc or docx format, and this format should consist abstract, introduction, working, conclusion, and the other stuff. Okay, so this is an ideology submission platform. Okay, so why is this a surprise? See, why is this a surprise is because you will not need to go ask a teacher. You will not need to go ask any fundings. You don't need to go ask for permissions. Okay, Team Vikasana will be providing you everything. Okay, we from Team Vikasana will be providing you each and everything that you require to make this idea into a reality. Okay, so why are we doing this? Is simple, because when we come up with such an idea or Vikasana, it was not easy for us. Okay, it was not easy for us to get a workspace. So we are trying to give a stage where it's predefined things for you. Okay, just a go sign from us and you're off to your aim. Okay, so that's the reason we are giving you this as a surprise. Okay, and yes, ideas can be popped by one or many, but as of now, considering this to be a bit of competitive world, we are going to stick with two maximum teammates. I'm sorry. Okay, so in a team they can be maximum of two or one. So I can't say minimum one because it is one. Okay, and once this is done, you can submit it. We will verify it, and once it is able to apply, we'll give you a go ahead sign with all the requirements, and you can go ahead. In case, okay, if your ideologies, okay, is not worth or not worth, I will not say it is not worth. Let's say it is not applicable at the right time. Okay, at this time, if it's not applicable, we will not reject it. We will keep it aside. Okay, once the future scenarios changes and if it is applicable, we will even go ahead with that. Okay, so remember, you will be having an opportunity to get all the spotlights you want. Okay, Sai Sharan Kumar. Okay, you are given a Rise fan. Okay, yes, Charan, you can unmute yourself.
Uh, can we get a mentorship like how to do implement the stuff whatever we have the idea?
Okay, you want an idea. Okay, fine.
I have an
Uh,
uh, can we get a
yes,
mentorship like how to implement that?
definitely. That is why we are here. So we will assign you things where you can get it. We will even try to give you seniors, or most probably, if the idea is very well, we will give you the teachers. Okay, we will try to get the teachers who have worked on that field, on that domain, and get a mentor for you so that you can improve your ideology. Yes.
Yes, right.
Yeah. Thank you, Sharon. If that was the case, you can roll your hand. Yes. So yeah, guys, that's it. And I presume that all your Tinkercad is up and running. So if I shift now, let me go to my Tinkercad dashboard. Okay. So this is the scenario which you had. So let me just create new circuit. This will take quite a little time. Okay. Before that, let me come back to you. Can any one of you volunteer? Can I see a hands? Raise of hand as a volunteer. Okay, Kirtiraj. Okay, Kirtiraj, you will be able to unmute yourself.
Yeah.
Yes, Kirtiraj. Okay, good. Kirtiraj, what should be my default components ready?
Arduino, you know.
Yes, okay. Let me just get my Arduino. Arduino. Yes. Okay, drag and drop. And what will be my next component?
If we studied about the push button, so next would be the push button part.
Okay, fine. In case if you want a push button, okay. Let me just keep this aside. Okay. What
Mm,
will be my default this thing?
a breadboard.
Yes, breadboard. So
Small.
now which of these three breadboards
Small.
should I choose? Small, exactly. Okay, so let me just drag and drop it. Yeah. Okay. Now I need to give a connection between the board and the microcontroller LED. So what should I require?
Wires.
No, no, what the components I'm asking.
I didn't get you.
Now I want to give a LED connection to the micro
Okay,
Arduino and the
LED,
breadboard. Yeah.
LED resistor,
Okay. LED. So I'm just choosing an LED and then
resistor.
okay, resistor. And can you tell me how can I rotate this resistor?
R by clicking the R key.
Okay, and what is the other method?
Then by joining
That-
the huh?
You have
Like
to
yeah, we have to convert it to like ohm or 22 resistance ohm.
yes, 22 to 20. And oh
Yeah.
yeah, just a second.
Uh,
Yeah. Oh, yeah. So this is done.
yes.
Thank you, Kirti. That was well done. Okay, cool. So let me get back to my circuit. Okay, now this is one LED. Okay, I will request all of you to get as many as LED as 7. Yeah. So I want 7 LEDs. Okay, I'm just gonna use 7 LEDs. Okay. Okay, I'm just gonna use 7 LEDs. So I can just drag and drop as many as LEDs I require. So we need 7. So I'm just choosing 7. Okay. And the last. Right. Okay, cool. Now, see, as you can see over here, if I start connecting a resistor, as we did it in the last previous class for each resistor, sorry, each LED, now then we will require a long, okay, or default breadboard. Okay, so what can I come up with an idea to change it as simple? Take the resistance, rotate it, keep it vertical, and just connect it over here. See, now you can connect this and this resistance directly with each other. Okay, so that will be done for the same. I'll just take a resistance, start dropping it on this. Okay, and remember you have to connect this on the longer side or the straight side, straight pin. Okay, so this will be done over here. Okay, and just again, yes. CS is this cathode and anode. All right. I will request all of you to do it along with me, and change the resistance value so that we can move ahead. Students, please be in sync with the circuit and in sync with my teaching so that it will be easier for me to finish this and give you far more details on Arduino Uno. Yes. And yeah, if you're hearing a lot of background music of bird chippings, well, yes, I have birds in my house, so that's the reason you're getting all those noise, rather than noise, kind of a music to me. So do bear with me and we'll get this workshop done. So let me just connect the ground, okay? So remember, as I said in the previous class, your presentation, your design part of the circuit is very important. Okay, why? Because when you present this to a viewer, you should be able to get impression, okay? Impression of telling that the viewer can understand the board without any requirement or without any prior knowledge. Understood? So as I said, red means active, black means dead. This is a technical term used by any technicians. Okay, so they always know that black means there's grounded, That means it is an active wire which will be having a passage of current. Okay, so once this is done, I would request you to, okay, just give me a second. Okay, yeah, yeah, got it. Now, as I said, I'm going to use a push button, right? So let me just take push button. Okay, I want you all to take two push button, keep one on the left and one on the right. Okay, just that. And now, if this is done, okay, what I would require you to start connecting these LEDs. Okay, start connecting all the 7 LEDs. Okay, I'm going to start from 2. Okay, you can start from your desired number, or if you have a lucky number, you can just start it from that, finish these connections, and I'll get back to you. Okay, I want you all to be in sync with the connections. Let me know once you're done so that I can move ahead. And if you're in sync with me, you'll be able to finish it fast and carry it and get far more better information. Okay. So guys, as you can see, I'm trying to be precise in my design. Why? Because the design will always look far more better than a random, you know, connections, right? So students, as you can see over here, this push button and the connection wire is getting overlapped. So try to make sure that this is not getting overlapped. Okay, so now we can see this is far more better than the previous this thing. Okay, so once you're done with this, okay, I would ask you to again rush back to a resistor, pick up a resistor, turn it around. Okay, turn it, and I'm sorry. Okay, take it and get it connected with the 2B. Okay, why 2B? Because as I said, I'm going to connect 0 volts. Okay, if I'm going to connect it to a 0 volt, which means it will be ground. Okay, so that is why I'm going to keep a resistance over there. Okay, and now see, I want to connect a ground. Okay, so the ground is over here. Okay, so I can take this pin and connect it over here. Okay, that will be bit more, a bit more kind of complicated. So what I do is I'm just going to connect it over the top. Okay, the same things goes over here. Okay, I'll just do it over here. And now as you can see over here, this has not been connected to the ground. So what can you do is you can just again drag it from this point, or let me do a thing, just take this and let me get it sorted by a wire. So as you can see over here, now this entire lane will be connected to the ground. So this will automatically be black because it is having ground wire. And see, as you can see over here now, see now this line of code is getting jumbled. Okay, so what will I do? Try shifting the push button. Okay, so why are you keen? Why are we doing this? Let it be as it is. Trust me, the design marks will be also given to your projects. Okay, to any certain given circuit, a design marks will be calculated for it. Okay, that's the reason I tend to keep my designs precise and presentable. Okay. Okay, once that is done, okay, let me just change this color because it is active. Okay, this is done. So once this is done, what I would like you students to do is, see, now I would like you to connect this 1B to the active. Okay, why active? As I mentioned, this 1B will be consisting of 5 volts. So that's the reason I'm connecting to the active. Okay, now these two pins are done. Now there's 1A and 2A. Which pin should I use to read? I'm going to use 2A. Why am I using 2A? Simple. See, if recall, 1A and 1B will be connected, interconnected. Okay, so if I take a reading from 1A, it will always be 5 volts. Okay, but if I take a connection from 2A, it will be 0. If the button is pressed, it is going to be 5 volts. So that's the reason I'm choosing this thing. Okay, so I'm going to just take this pin, okay, which is number 12. Okay, let me just get it over here. Mhm. What did it do? Let me just see. Okay, so yeah. So this is going to be my input for the next pin. Okay, just keep a bit of gap. Okay, so this is done. Now I'm going to change this color to orange. So if you may ask, why are you changing the color to orange, sir? So let me say that this color, okay, I am naming it as an input, okay, because I'm reading the value from the pin. Okay, I'm not assigning any values to it. I'm reading the values from it. Okay, that's the reason I'm choosing this color. Okay, so sorry. Okay, so this is the reason why I'm just choosing. So if you were in sync with me, this is how your Arduino Uno board should look like. Okay, you can do this, or you can even connect it. I'm so sorry. Or you can just connect it to the exact pin where it is available. Okay, you can do it any of the required manner. Okay, because this is it. So let me get back to you. Okay, I'm being a bit fast because of the time constraint and because we have already finished day shop 1. Okay, workshop 1. So now can I see a number of ants who are in sync with the circuit connection? Okay, I see 1, 2, 6. Okay, 8. I assume that my screen is visible to you all and you can see the 37 attendees. So yes, okay. Thank you. Students, you can kindly lower your hands. Okay, and the students who are yet to do the circuit connections, do you want me to wait? I mean, do you want me to, display the circuit connections? Give a raise of hand. Okay, Kirtiraj. Yes, I got it. Is there anyone else with them? Okay, fine. Kirtiraj, please take the time and get it done. So as you can see over here, the circuits should be as precise as it can be. Okay. Or if you have any other designs, you can do it, but make sure it is presentable. Okay. So that when you look at the circuit, you may know that, okay, this has been designed by profession. Okay. So that's the reason I ask you to be precise in your presentations. Okay. So as I said before, the surprise was given, so I don't guess I need to tell you more about it. But if you guys really need to know more about it, please stay back in the meeting. The PR department will explain you the details, the rules and regulations, the terms and conditions, the each and every part of it, and give you other some informations regarding the team Vikasana. Okay, and if you know or don't know, recently we just got an information telling that we had submitted a module for Robocon. Okay, and we got 100% success, and we are among the top three of the colleges who gonna represent India in the national level Robocons. So yes, I'm proud of my team, and yep, claps for each and every one of the Vikasana members who have achieved this. hmm So yep, let's get back. Okay. All right. So now I guess we can move forward without any delay in secured connections. So can I see our Riser fans to go forward with the coding part? All right. All right. Cool. See, as I said earlier, I would require minimum Riser fans to go forward. So I see 10 out of 37. If I could get a few more, and I will be able to go ahead. Okay. Yes. Thank you, students. You can kindly lower your hands. Yes, students, I want to take a quick look in the chat box. There is attendance form link provided over there, and it will be active for 5 long minutes. So just go and jump into the chat box, give your attendance, and come back. Remember, I will be taking an attendance at the very end of this meeting, and that attendance list will be cross-verified with this. And if you're present in both, that's the very crucial part to gain a certificate. Okay, so if you want to take a certificate, you need to give your attendance over here. So please go over there, give your attendance, and come back and put a message telling that you're done with attendance. So students, remember, this will be active for 5 long minutes. So do it as soon as possible. Okay, ASAP, and come back. Drop a text telling that you're done with attendance so that I'll be able to go ahead. Yes. Okay, Sai Charan Kumar. Okay. Uh, can I address you as Charan, if you don't mind, because you've got quite a few names. So, how do you want me to address you as? Lanka Venkata Sai Charan Kumar. Drop down your name so that I'll address you using the same name. Or is Sai Charan fine with you? Cool. Thank you. So to remember, the attendance form will be active for 5 long minutes. I will wait for you guys. Go into the form, fill it up, give your attendance, come back and put a text telling that you're done with attendance so that I can move forward. Okay, Sanju. Yep. So, cool. Few more and we'll start going ahead. Okay. All right. Yes. Okay. Pritham, you can check in the form and you can close the form. Yeah, fine then. Let us jump into the coding part. Students, please stay in sync with me. All right. Now I'm gonna open my coding part. Okay. Oh, wait, let me do one thing. You know what? Actually, come on, man. I'll take another volunteer now. Kriti, you have done the last time, so thank you. I will request some other volunteer to come up. Just raise a fan. 1 out of 37. Anyone. And yeah, I will not be going ahead and I will not be picking. I don't like to pick students out of their own comfort zone. So give a raise of hand. Okay, Sai Kumar. Fine. Yes, Sai Kumar, you will be able to unmute yourself.
Yeah, I can.
Yes, Sai. I'm sorry, Sai Charan. Okay. Let me just clear this off. Okay. What will be my first function, Sai Charan?
It's setup function.
See, I'm going to type as per your command, so please be precise.
White setup.
Yes, why setup.
So
Okay,
pin mode of
and
13 comma input.
pin mode of.
13 comma input.
Okay, you want to jump to 13 comma input. Okay, Sai Charan, let me do one thing. Why don't we start from ascending order? Why don't we start from 2?
Oh yeah. Okay. 2
Okay.
comma output.
Okay, output in all caps or small, Sai Charan?
Oh, it will be in caps.
Okay, good. Remember, work hard is good, but I would say work smarter. Okay, why smarter? Because trust me, in the given scenario of life, being smart is better than working hard. Alright. So yeah, Sai Sharan, can you repeat the numbers 2, 3, 4, and
2, 3, 4, 5, 7, 8 will be the output.
okay. Let me just give it a next line. And I tend to be a fast typer, trust me, because if you're a coder, you need to be a fast typer. Alright. Okay, Sai Charan, next is pin 12.
It's pin mode of 12 and 13 will be the input.
Okay. So what should I give it over here?
Pin mode of 12 comma in caps input.
Okay. Is anyone finding any error? Okay, let me just point out that see, I did it on precise because see over here this pin P is in caps. Understood? Since I said this is a case sensitive, you should also be very sensitive when you type. All right. So pin mode input. Okay. Can I give any other pin mode side channel?
No. And will
Okay.
be set.
Yep. Thank you, side channel. Well done. All right. Okay. Just let me just come back. There's a chat over here. Done. So yeah. Thank you, Vinay Reddy. Yep. Cool. So try to be in sync with the coding part. And students, if you're coming right now, don't worry. I'll give you some time. Check out with the coding part. It is just pin mode functions. Okay. Check up over here. So this is our just pin mode functions. Okay. There are 7 output and 2 input. Okay. You can check out the color. Orange is for input. So there are 2 orange, 2 input, and there are 7 green, which are output. All right. Now let me just start with the while loop. Good. Okay. And as I said, being a fast typer is good. And if you ask me, sir, how do you do it? Simple. Take a book, start typing into the word. And the more faster you get, it is more precise. And yes, okay. So is it necessary? Well, yes, it is necessary because some companies will tend to check your typing speed. Okay. If you have an account in LinkedIn, trust me, LinkedIn, it keeps a competition to check how many, words or letters you can start typing in a second, a minute, so that depends a lot. All right. Okay. Now jumping to the logic. Okay, let me just try this out. See, now you see there's a push button on the very left. Okay. When I click this push button, I need few of my LEDs to glow. Okay. And when I click on my other right side push button, I need few LEDs to glow. Okay. So differentiating this in a easier manner, what I'm going to do is I'm just going to click on my LED and I'm going to change the color. All right. It's lagging a bit. So just, yep. And I'm going to give it blue. Okay, red, blue. Why blue? Well, blue is kind of a favorite color of mine, and it is good with red. Okay, red, blue. It gives you a good kind of view. Okay, so once you're done with this, let me get back to my own basic logic. Now, just a second. Yeah. So when I click on the leftmost push button, I would require all my red LEDs to glow. Okay, and when I click on my rightmost push button, I would require the blue LEDs to glow. Okay. Mm, so that's the basic logic. So stick with me. And students who were in filling of the attendance, if you're back, consider the code above, set up and try to catch up. All right. Now, okay, fine. Now what I'm going to use is I'm going to use the if condition. Okay. I've explained this if condition in the last previous class. So if it is true, one set of codes. If it is false, another set of codes. Okay. So what am I gonna sense over here? So what I'm gonna read over here is like digital, okay? Digital read. So digital read of which pin? I'm gonna choose pin number 12. Okay, that is the rightmost push button. Okay, so why are you using digital read and is there no other in lower I? Because you're reading it, there is no lower I. Only if you write to it, it will be lower I. Okay, remember, if you're reading it, okay, it will be always just the pin number. Okay, so digital read R is in capital. Okay, and I'm gonna compare this with another value. So I'm gonna use equal to equal to. So double equal to is nothing but and relation operator. It will compare two values left, RHS and LHS. Okay, the LHS it is digital read 12. So in the RHS I'm gonna give high. Okay, so let me consider this. And so what did I say? If I'm going to take my left push button, I would require only the red LEDs to blink. Okay, so I'm going to say digital, right, W in caps. Okay, so what are the red LEDs number pin? So it will be 2. So it's comma 2 comma I. Okay, this done. Okay, as I said earlier, be smart. Okay, and work smarter. Okay, I guess, yeah. That's the number of LEDs to glow. Okay. I'm gonna say 3 and I'm gonna say, I'm so sorry. This is gonna be 4. Okay. And the next number will be 6. The next one will be 8. Okay. Why? Because you can see the assignment of the pin numbers. Okay. And this is done. Now I want to see that I know I told you only. Okay. See, when I press or when I suggest this word only, it means that exactly only those LEDs should glow and no other LEDs should glow. So I'm going to turn the other LEDs as off. So I'm so sorry. Right, which are the other pins? 3 comma low. All right. So let me just copy this. There are 3 more pins such as this. So 3 more pins and this 3 and the next pin is 5 and the next one is 7. Okay, so this is the code and the same thing applies for the rightmost push button. Okay, if okay, let me just okay, if okay, what we are supposed to do, digital read. Okay, digital read of which pin? 13. All right, then compare it with I. Okay, and then give a set of proofs. Oh, I'm sorry, set of codes. Okay, what is the best method? Go top, copy. Select this, copy this, come back and paste it over here. Okay, make sure the alignment is done properly so it will be easier to read the codes and decode the codes. Okay, just do this. Okay, so this is done. And as I said previous, I want only the blue LEDs to glow and not the red if it is the rightmost push button. Okay, so let me just copy this and paste it over here. Okay, I'm gonna name this as low because that will be making the LEDs off. Okay, this is done. Okay, and few may have a doubt. So why are we not using an else part? Okay, I'll just get back to you. I'm so sorry. So my laptops. Okay, let me get back to you why I'm not using else part. Okay, let me just check if my code is error free. And Yes, it is error free. Okay, let me get back to you. Okay, can I see the number of ants who are in sync with me? I mean, in sync with the coding part. Okay. So I keep mentioning this that I will stick with each and every one of you so that you will gain the knowledge no matter what. So I will definitely wait till I see responses. So till I get a minimum response to go ahead. I'm so sorry, but I won't be doing that. So there's 10 and there's 37%. So I need a few more rise of hands so that I can go ahead. Okay, cool. Three more. Can I get three more rise of hands? Okay, the students who have done it, very good. Kindly lower your hands. Good job, guys. The ones who are yet to, still lagging behind, I will wait a second, a minute for you. Okay, please go to the course, get it done, check the circuit part, type it. Okay, get the connections done, and then I'll tell you the simulation part. Okay, just give me a second. I'll Yeah, I guess I can just go ahead with the simulations. Students who are lagging behind, please do catch up the pace because I'm so sorry. Jyotish, am I not audible to you, Jyotish? If so, give a rise of hand. I mean, if I'm audible, give a rise of hand. Stephen Raj, Venkat Sai Charan. Okay, cool, Jyotish. Okay, fine. Thank you, Saichana. You can okay, fine. Let me now jump to the coding simulation part. I'm so sorry. Okay, now let me start simulation. Okay, it is initializing. Okay, it started. Cool. Now see, let me just zoom in. Okay, see this push button. Okay, what do you mean by push button? When I apply pressure, it is inside. Okay, when I click it on, it is inside, and the lights are okay. When I take it off, it comes up, it pops out, the light are still burning. Now if you go for the next push button, okay, like as you can see, I'm just gonna click on that. Okay, I'm gonna apply pressure. See, the blue lights are lighting up, and the red ones are off. Okay, and when I go back to that, it's vice versa. Okay, so now for the persons, or if you had a doubt why I have not used an else part, okay, let me just put an else part and give you why I have not used an else part. Okay, let me just start my simulation. Okay, so now let me just click see I'm going to apply pressure on this, and the red lights are glowing and LEDs are glowing. So when I remove it, it goes off. Okay, and the same thing over here. The blue ones are on, and if it is off, it's off. Okay, so that's the reason why I have not used the else part, because you need to have a keen pressure. Okay, so I'm so sorry. Yeah, so you have to have a clean sense of pressure over there to gain. Okay, stop simulation. Okay, so that is the reason why I'm not use this else. Okay, because if this else is used, that means that I have to keep on having pressure on the push button. Okay, so that's the reason I'm not used the else part over here. Okay, so see now I'm just going to click this, and once it off, remove my pressure, it's still on. And when I go back to this pressure, and when I take it off, it's still on. Okay, so let me get back to you guys. All right. So now, can I see a number of riser fans who have completed the simulation and got the output as such as the shared output? Okay, cool. That's 9 and few more hands up, and we will go forward with the next thing. Okay, there's a chat in the box. Just a second, students. Okay, I see 9 members of Riser fans got buggy. Okay, we got an error. Okay. Just get back to you. New participants. No, I guess, Venkat, I guess you can be, you'll be able to unmute yourself. Try unmuting yourself, if that's possible. No, okay. So, do one thing, Saichan, if you don't mind, can you type out the error which you have got, or what is the error you have got? Can you give a snapshot of it in the chat box? Yeah, and other students who have raised their hands, thank you so much. You can kindly lower your hands. Sai Charan, can you give a snapshot of it in this thing? And okay, but I'm not getting that option with you. Yeah, Sai Charan, can you give a riser fan for me to unmute you? Yeah, okay, the other is Shabir. I don't know if I'm pronouncing this right or wrong. Shabir, if you don't mind, can you kindly lower a hand, or if it is a hand put out? Yes. Okay, yes, Saicharan, I guess you'll be able to unmute yourself.
Yeah, now I can.
Yeah, tell me
Yeah, I
the
had
bug
shared
you
the
have got.
screenshot in the chat box.
Come again.
I had shared the screenshot in the chat box.
I guess it's taking a bit of time to load. What was the exact precise error did you get? Can you read it out?
It's in the code, it's showing only the red lines, no errors no errors actually, but I'm not able to execute the program properly.
Come again, there are no errors.
No errors, but showing the red lines in the code channel.
Okay, that is due to the Chrome settings. Okay, sometimes that gets stuck over there. You can refresh it or can go back and come in. Understood?
Yeah, sure.
Yeah.
Thank
Did your simulation take part as per my simulation?
I tried actually I declared the push buttons in the global variables.
Okay. No, but did the simulation give the same output as mine?
Yeah, the output will be the output is same, but I'm getting this buggy like the red color.
Yes, the red highlighted one, right? So try
Uh,
going back to the dashboard and try coming back, okay? That error will be removed.
yeah.
Yeah, okay, Saijan. Okay, fine. So now let me into the next session, okay? Okay, now, okay, so let me do one thing, okay? You see, you see all these lines of green lines, right? So I want you to go back and get me Arduino on a board and these 7 LEDs, okay? There's no need of having the change of color, but I want you to go and give me these 7 LEDs and these connections, okay? I have already done this in the earlier batch, so I'm just going to jump to it, and I'm allowing you to do it because it is easy for you because it has been taught 3 times, I guess, considering in the module 1 2 times and now 1 time. You will be able to give this connection without my help. So let me see if you are able to check this. Okay. Okay. I forgot to ask this. I'm so sorry. Does anyone have any more errors or any more doubts regarding the previous experiment? Okay. I'm assuming no one has any more doubts or errors in the previous experiment. So let me just jump to this next one. Yeah. Yeah, Saicharan, I guess that can be just this one, a Chrome error. Okay. Guys, please do bear with me. Even I'm undergoing the same buffering as you are. So, or if you are able to get the dashboard, go create a new circuit board, create a newer circuit, okay? Because I have already created for the previous batch, so I'm going to use the same thing. So I want you to get the circuit done, okay? And I'll be providing you with 3.4 minutes, okay, which means 3 minutes 40 seconds. Why? Because that is a minimum maximum time required to make this board, okay? So please do get it, and I'll just come back to you guys, and we'll move forward ahead with the circuits which you have completed, okay? I guess it is easier for you guys, right, to do this on your own. If you still need my assistant, please do put text in the chat box so that I can assist you. Okay, okay, it's loading up. Let me just come back to you. So I repeat, if you still need my assistant for doing that connection, give drop a chat. Drop a text in the chat box so that I can get back to you and assist you in your circuit connection. All right. Seeing no replies. Okay, fine, good. Let me just mute myself, and I guess yeah, the birds are making a lot of noise. I'll just get back to you guys, okay? Still then, just do the circuit part and I'll be right back. Yes. Can I give students? Can I see a raise of hands for who have completed those circuit connections? Six. Hmm. Let me be clear. I requested you all to do the circuit connection. So, is it tough or is the net lagging for you guys to finish up the circuit connection? Okay. Students who have completed, kindly lower hands. Thank you so much. Students who are yet to complete, can you give a rise of hand to tell me what is an issue? Suprit, okay. Suprit, do you have an lag in the net or do you? Okay, no, fine, not you. And may I know why the other 33 are still yet to complete the circuit connection? And yes, for the students who are, you know, left the meeting, remember, I will be taking attendance in the very end and cross-verifying with the attendance form from Google. So attendance is crucial for your certificate. So I will be bit strict in that manner. But still, let me get back to the topic at hand. How many of you have completed the circuit connections? The ones who raised before, please do raise again. Let me get a proper count, minimal count, so that I can move ahead. Okay. I still see the same number of systems. Okay. So there's Narasimha Kumar. May I know why are you lagging behind? Okay, sorry, that's racist hand. Okay, there's Ashwini and there's Sanjay and there's Vinaya and there's Swarup. May I know why are you guys yet to raise your hands or are you guys in still the process of getting the circuit connections done? Okay, that's done. Okay. All right. Yashaswini and Sanjay, Swarup. Okay, Yashaswini is just reading the meeting. All right. Okay. Right. Okay, fine. Students, yeah, thank you. You can kindly lower your hands. Let me just jump to the coding part. And the rest of you are in lag. Please catch up with. All right. A moment, guys. Yeah. So after you do this, okay, let me just open the coding part. Let me just clear this. All right. So see now if you said seen the earlier codes, okay, just the previous one, you had to give pin mode 8 times to define it for 8 of the LEDs, right? So what I'm gonna do is I'm gonna define an array. Okay, I'm gonna define an array named as LED pins. Okay, square bracket is equals to power bracket, and I'm gonna type the pins. Okay, so I've chosen it from 2, so you can take the pins as per your design circuit. So 2, 3 till 8. Okay, and I'm just gonna end it with a semicolon. Okay, students who have known or do know the concepts of array, well and good. Okay, and students if you don't know, fine. Let me just give you a simple ideology. See, you must have seen a bookshelf, right, in a library or given it at your home. In that bookshelf, you stack the books. Okay, you stack the books in an orderly manner. Okay, if it is belong to fiction, you keep it under fiction. If it is under humorous, you keep it under humorous. So that's the same manner. If it is under integer, only those kind of elements can be kept under LED pens. If it is under character and so on. Okay. Now that's done. So now if you want to take out the first book, okay, or now let me say I want to take out the first pin, which is 2, okay, then I should be giving an index value over here suggesting the place of 2, okay. The place of 2 is first, yes, but the array by default will be assigning 0 to 2, okay, so it will be 0 1 2 and so on, okay. Now let me just jump into, okay, just come back. Is the array function clear to you all? Please give a raise of hand. Is the array concept clear to you all? Okay. Okay. Students, kindly lower your hands. Okay. Now, students who think that they can give another example, or if they think that they are yet to understand this concept, they can give a raise of hand so that I'll be explaining this once again. You can give a raise of hand, or you can even drop a text in the chat box. Okay, fine. Let me just go ahead. Students, if you don't mind, I'll just go ahead with the setup function. Okay. So setup function. Okay. Now in the setup function, so the main thing which I'm going to teach you over here is for loop. So if you are wondering what is a for loop, now for loop is same. It repeats the steps of code again and again, but in the for loop, it will have a variable which will terminate after a certain point. Okay, after a certain condition, it will terminate itself. Okay, so now I'm just gonna declare a variable inside a for loop. Okay, for loop integer. So the default is I, so I'm just gonna stick with I. I is equal to 0. Okay, semicolon, and then I'm gonna say that I and the limit. So the limit is gonna be 6. Okay, less than or equal to 6. Okay, by 6. So simple, or I can give it even as 7. Okay, why 7? Because there are 7 elements, right? So I'm going to keep it as 7. So when you start counting from 0, the sixth will be counted as 7. Okay, and the next condition will be discarded. So if it is 7, 7 is not less than 7. Understood? So that will be discarded, and I'm now going to apply increment condition over here. So what does this increment condition do? If you know, well and good. If not, well, increment condition is nothing but it's going to just add 1 to the given variable. Okay, let me just give the set of codes and then come back to that increment part. Okay, now the code will be pin mode. Okay, so pin mode can take only one pin, so I'm just going to take LED pins. Okay, LED pins, square bracket, and I'm going to put I. Okay, so that value of I will be given over here, and I'm going to assign it as output. Okay, so I'm just going to assign it as output. Okay, and semicolon. So once this is done, the I value will come directly over here. 0, yes, it is I. 0 is less than 7. Perfect. It assigns it as output. Then it gets incremented I plus plus. The same way it will come back and keep 1 as an output. It will go back, get incremented to 2, and check with this condition I less than 7 and 2 is less than 7. So on it will go till it reaches 7. Okay, why I'm telling you 7 is because when it reaches 7, it is going to check this condition. Now 7 is not less than 7. 7 will be equal to 7. Okay, so when this condition applies over here at the time of 7, I is equal to 7, it will automatically terminate. It will automatically terminate the loop and come out of the loop. Okay, so that is done. Now let me just jump into void loop. Okay, as I said, be a bit fast in typing so it will be helpful for you in the typing process. So I'm just going to use an X over here. Okay, because as I said, you can give any variable name. Okay, I'm just using the X over here. Semicolon I plus plus. Okay, I'm sorry, this is not I plus plus, it is X plus plus. You have to increment the given variable or the decrement variable in the for loop. Okay, and I'm going to say digital write of the pin of LED pins with the number X. okay, comma, high. So this is done. But I want the LEDs to not to glow but to blink. So I'll just give a delay of 500. Okay, that means half a second. And then I'm just gonna go back to digital, right? Okay, and then I'm gonna say LED pens square bracket of X, comma, and I'm gonna make it as low. Okay, this is done. Okay, so do check this thing, and the follow-up as explained earlier over here, it will be the same thing. Okay, let me just come back to you. So may I get a rise of hands in number of people who are in sync with the coding? Okay, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 12. Sanjay, Narasimha Kumar, Vinaya. Okay, 14. Yeah. Thank you, students. You can kindly lower your hands. So once you're done with this, okay, let me just check if there is any error in my code. If there's no error, it will automatically start the simulation. Okay. Initializing. Yes. So if you guys could, observe the LEDs over here, see the LED pins are starting to glow in a serial manner. So that's the why I've named it as serial. Okay. So this, acting in a serial manner. Okay. Now this is acting from left to right. Okay. So this is blinking from left of this LED to the right of the given serial. Okay, what if I wanted to get a rebound? Okay, what if I want to be like left to right and again from right to left? Okay, in that circular manner. So what I'm gonna do is over here, I'm just gonna add another follow. Okay, I'm just gonna add another follow and I'm gonna just keep the variable as x because I've used the same variable as x. So I'm gonna assign a number known as 6. Okay, and the semicolon x greater than or equal to 0. Why 0? Because that's the least number of the index, and I'm gonna decrement it. See, if you're gonna increase the value from 0 and 7, it's gonna be increment. If it is 6 and 0, it's have to be decrement. Okay, remember that the simple logic. Okay, after this is done, I'm just gonna take the same code. Okay, there's no change in codes. Okay, let me just do this. Okay, and now if you start the simulation, see, it is started to glow and it's coming back in the same order it went. As you can see over here, it's moving from left to right, it's going over there and coming from right to left. So that is the orderly fashion. Okay, that is what this does. Okay, so let me just come back to you guys. Okay, so now can I see a rise of hands to the students who have completed the given experiment? Okay, well done, cool. 3, 4, 5. It's just another follow with a reverse algorithm. Okay, I'm just using a reverse algorithm over there. I would have taught you the logic before that algorithm, but given the time constraints, I have to end it as early as possible. So, but that doesn't mean I will just go ahead if I don't get a minimal response. I'm so sorry, but I will stay back if I don't get a minimal response. So, few more hands raised, and I will be able to go ahead with the workshop. Four more. Can I get 4 more raise of hands? People who have completed the simulation part can kindly give a rise of hands so that we can move ahead. Okay. Oh, there's Sanju, Nandini, Jyotish, Sinchana, Saujanya, Swasas, Sukanya. Guys, to give be interactive in the workshop so that you can tend to learn more. Okay, 14. Yeah, students who have raised their hands, thank you so much. You can kindly lower your hands. And the students who are getting lag behind, don't worry. You can get in contact with the PR department and they will help you to complete this experiments in your own given time. Okay, but since I'm having a time constraint, I'm just trying to go forward. Okay, so this is done. Okay, now I'll be talking about a day-to-day used component. Okay, the components which we use in a day-to-day routine. Okay, so let me just go over here. Uh, Let me just remove this. Okay, yeah. So as you can see, these are the module 2 and module 4. So module 3, okay, is done. Now I'm sticking with module 4. So what is going to come out of module 4 is another two components. Okay, these components, I'm 100% sure that we have used this in our life. Okay, so next is IR receiver and transmitter. So as you can see in this image, there's a remote and an IR receiver and sensor. Okay, this is a receiver. Okay, this is a receiver which is nothing but a sensor. Okay, and now let me just highlight this. So receiver and transmitter. Okay, so yes, as you see, there's a remote over here. Okay, so yeah, this remote can define your television remote, TV remote, or your DVD remote, or the AC remote, or the remote for your lighting system. Okay, so this is what they use. Okay, and when you look at a remote, you see there's an LED in the front of the remote or in the head of the remote. Okay, so people say that there's no glow in this, but it's still work. How do we know it's still working or not? Well, trust me, it is working because that LED tries to transmit a light in the range of infrared light. Okay, and this light is not visible to a human eye. Okay, so that's the what is it, medium or the wavelength where it communicates with the IR sensor. Okay, so that's the reason. And there's a definition given over here. So is what? Okay, it uses infrared light which is not visible on a human eye. So that's why a good option for wireless communication is what is mentioned. When you press a button on the transmitter, that means a remote, an LED on the transmitter turns on and off continuously and causing a modulated infrared signal to send from the transmitter to the receiver. So as I said, it is going to transmit to the receiver and that will be in the given component. I'm so sorry. Yeah. So now, so why are we even learning about this? Is simple. Take a robot. Okay. If you There are three types of robot: automatic, semi-automatic. Okay, and there is manual. So if it's going to be a manual, you need a control system to control it manually. Okay, even if it's semi-automatic, you will require a control system to control it or manually. I mean, I know by the human who has created it. So now to get this information, we need to try to communicate between that. So we can apply as a basic, okay, as a very base technology. You can use this IR transmitter and receiver. Okay, you can use this in robotics, you can use this in drone, or you can even use this in your life to day-to-day life systems. Okay, that's the why we are learning this. Okay, and the connection part is pretty easy. Okay, and as I said before, I have taught this in the beginning of the batch, so I'll be just taking it up. Okay, so in the meanwhile, I will request you all to open and create a new circuit. I would like you all to select Arduino Uno board with the IR sensor and IR remote. Okay, so in the meanwhile it gets loaded. I would request you all to open and get it ready. So see, as I said before, as a surprise over the idea submission, do take a minute to think about it, okay? Because even if it is a simple idea, trust me, after some you know, brainstorming, that will turn out to be the best idea. Okay, that is how people have come out with a lot of ideas when you check for Zomato or when you just check for Ola and all. No, these are not just people who just popped out with a get an idea. Okay, they just started with a normal idea telling that no, I just want to eat, let's go out. And they said at this kilometer, okay, and let us say now in within 1 kilometer I can get this food. Within 2 kilometers I can get that food. Okay, and within 3 kilometers I can get a better food. But they didn't want to travel. So they called up the this restaurants and they said, can you do home delivery? They said, sir, we can't do home delivery because we have no such accommodations. So what that is when they started thinking and they're like, why can't we start up a company which does delivery? Just a delivery. And that is when it popped up, Zomato, Donzo, and the same way before you used to use cab company number, but now it's just Olo and Uber. I'm so sorry. Yeah. So that's the way. So don't think that you are just having a simple idea. Trust me, you will have a better idea no matter what. Okay. All you need is just a bit of brainstorming. uh, Given the right tools, well, you can create your own robot in just minutes. Okay. When I say minutes, I'm not actually telling you minutes. Okay. When I say minutes, I am telling you in the month of, metaphorically speaking, in a month. Okay. Okay. This is taking a while to load. So yeah. So do you guys have any other doubt regarding? I'm so sorry. I didn't mean it. So do you guys have any other doubt regarding the workshop, or do you have any doubts regarding the experiments? If you do so, give a text in the chat down or give a raise of hand so that I can acknowledge you and clear your doubts. All right, fine. Let me just get back to my thinker. Yes, so this is the basic connections. Okay, so this is an IR. Okay, let me just tell you how to get this IR. So just go components all, and I'm just gonna type IR sense as a IR sensor. So just gonna pop up. So how do I know how to connect it? Simple. See, when you go and zoom in on the IR, you get ground. So ground means, remember, G and D is black ground. Power, which means VCC, power will go to 5 volt red. And then the output, it can be given to the your desired pin. I have used 2 over here. Okay. Let me just remove this. And then I'm going to take IR remote. So I can just drag and drop this remote over here. Cool. And I have used LED. Okay, let me just change this. Okay, let me just change this towards the LED and teach you why I've taken an LED and a bulb. Okay, and I've not used a what do you say, a resistor over there. So I kindly suggest that you don't also use resistor so that I can implement what can be done. And for a bulb, okay, you have to just type bulb and yeah, so sorry, and you get the light bulb over here. Okay, keep it aside. I'll tell you what can be done with this. So this is the connection part. Okay, I request you all to do the connection part and come back. I'll come back to you in a minute. Okay, just give me a minute. Yes. So can I see a raise of hands who have completed the connections? I mean the circuit connections. Okay. All right. 7 out of 33. Okay, cool. Thank you, students. You can kindly lower your hands. And I'm assuming all are in sync with the teaching, so that I will jump for the coding part. Okay. So these are predefined codes. Okay. I had actually given the same codes over to the other batches, so I'm just using the same codes over here. So as you can see over here right now, see, I have predefined this. Okay. Why have I predefined this? Because I'll be using it a lot of times in the given below code. So I have mentioned IR sensor. Okay, I have mentioned IR sensor as 2. So as you can see over here, it has been connected to the pin 2. So that's why I'm taking it as IR sensor 2. Okay, and then the LED as 13. So you can see over here, this has been connected to 13. Okay, it has been connected to 13. Okay, and next is watch setup. Okay, in the watch setup, there are only 2 pins which I'm using. Okay, the other pin over here is ground, so there's no need of mentioning that. So as you can see over here, pin mode IR sensor. So pin mode 2 will be input because I'm reading it from the given sensor. Okay, and then the LDR will be an output. So I'm so sorry. LED will be an output. Okay, this LED will be an output for me to observe the output. Okay, I have given serial begin. Why? Because I'm gonna try to even observe an output in the given serial monitor. Okay, so serial monitors over here. So I'll be even trying to get an output over here. Okay, so that is done. So now just a second. Yes. So that's done. Okay, now when I jump into void loop, okay, so void loop will be consisting of int status sensor. So why am I storing this over here? Because this, as I said, is gonna be transmitting on and off continuously. Okay, and I don't tend to keep it in that state. So I'm just gonna take it one or an average of the read. Okay, so digital read IR sensor. So I'm gonna just take this IR sensor and I'm gonna store it in the given status sensor. Okay, once that is done, my aim next will be to go and print. Okay, so I'm just printing in the next line as IR demonstration. Okay, I'm just demonstrating what is an IR going to work as. Okay, so that's why IR demonstration, and then I'm using a if condition. I'm checking the sensor with low. So you may ask me, sir, why are we using low over here? So let me just go back to the circuit. See, now you can see this is 5 volts. Okay, so this is an active wire. So this wire will be internally connected to 2. So 2 will always be high no matter what. So only when you press a button or use a remote will that send a send a wave and tell the sensor to break this. Okay, it will say us to break this current circuit, and then the value of 2 will be low. So if I press a button only and then will the value be low. So that's the reason I'm using the low value over here. Okay, so status sensor, I'm checking if it's low. So if it is low, what it means? It just means it is doing some work. So that work will be nothing but turning on the LED. So I'm just turning on the LED as I. So blink it, and I'm printing it as I also so that I can see it. Okay, and then I'm coming back over here. So just I'm coming back over here. Okay, and then what I'm gonna do is if it is not I, so what it means, the LED should go off. Okay, because once I put it I, there should be an option to make it low. Okay, so I'm just gonna put it as low over here in the else option, and then I'm also printing it as LED off. So IR demonstration LED will be off, and later if it is low, IR demonstration LED will be I. Okay, all right, and the students who are no, just typing records, just give me a second. So how many students have completed the code and are in sync with the teaching? Please give a raise of hand so I can see if I can move forward or wait for others to wait to code. Okay, I see 3, 4, 5. Okay, these students, well done. You can carefully put your hands down. Students, the rest of the students, please do check out the coding part and complete it as quick as possible. All right, I'm just highlighting this. Let me come back in a minute. Okay, just give me a minute. Okay, Kirti, yeah. Yeah, students, I'm now proud to announce that Team VIKASANA, we had actually registered an event, okay, a competition, okay, and that competition was a national wide competition, and I'm so proud to announce that Team Vikasana has scored 100 out of 100 in the stage one. It is a RR, it is a Robocon competition. So next we'll be representing, our college in a national level. Okay. So out of India, this is a national level college which is going to be held, and we will be representing Presence University in this competition. So kudos to all the teammates who have put in hard works on this. And trust me, it was not easy because we used to stay back. I know teammates were staying back and doing a lot of work. Okay, so that's the only reason we were able to come up and achieve this great victory. So I'm just announcing this to you guys because see, that's what you get when you try to put in a bit of work. Okay, if a lot of people start to put in a little bit of work, that's what coming up output will, or the result will look like. All right. So that's that. Mm. So I'm just coming back to you guys. Okay. Can I see a number of ants who have actually completed the coding part so that I can go forward? 11 out of 13. Two more. Can I see two more raise of hands so I can go ahead with the code, simulation part? Okay, fine. Thank you, students. You can kindly lower your hands. Students who are lagging behind, don't worry. When I start the simulation, the coding part will be visible to you. You can still code and finish up the coding part along the simulation. All right. Okay. So let me just start the simulation. If I am having no error. Okay. So yeah. Yes. There's no error in my this thing. Okay. Let me just pull up my serial monitor so I can see over here. As you all can see over here, students, it is LED off, LED off, LED off. Okay, but when I click on this thing, I'm so sorry. When I click on a button, okay, you can see that LED is on. Okay, and stays for there for 5 seconds. Okay, now I'm just gonna use another button. Okay, EQ button or something. So as you can see over here, there's an info telling that usable lifetime of LED may reduce. So that's the reason why we tell you to, actually gain that connection, okay? Because when this is the part in a physical world, you would have lost an LED. Okay, you would have lost an LED because the power is too much that an LED will reduce its life or get burst. Okay. Oh wait. Let me just show you that too. Okay. Let me just show you what do I mean by burst. Okay, and start simulation. So you see, current LED is 43 while the absolute maximum is 20. So that is the very reason why we tell you to use an resistor. Okay, because LED doesn't come with an inbuilt resistor. But when I go for an electric bulb, okay, electric bulb, well, it will be having its own internal resistance. Okay, so when I do this, okay, I'm not changing any values. I'm just starting the simulation. Okay, as you can see over here, it is on and off. But when I start this thing, okay, see, you can see over here, the bulb starts to glow, but there's no info. Okay, there's no, that is not giving me any error or it is not giving me any warnings such as an LED. Okay, because this bulb has an inbuilt resistance. Okay, so as you can see over here, this starts to glow without any, see, without any errors. It starts to glow. And what happens if it is connected to, just a second, 5 volts. Okay, let me just give that simulation part to you also. So you see, it is having an inbuilt resistor so that it is not bursting out. But as you see in an LED, it doesn't have an inbuilt resistor. So that's the reason we specify to use a resistor when you use certain kind of components. Okay, so it is off. Let me just check some other button. It's working well and fine. Okay, so that's the reason I have used this thing. And as I said, you can use this in any of the given project as well. Okay, to control the light or the color of light. Okay, in an LED, RGB. Okay, something like that. Now, okay, let me come back to you. So can I see a raise of hands for the people who have, I mean, the students who have actually completed the simulation part? Okay, 10 members out of 33. Can I see? Okay, let me see. There's a text. The bulb is not glowing, but the LED was working. Okay. Kirti, do one thing. You said the bulb is not glowing. Can you just check the connection in that? LED is not glowing. Okay. Sai Charan and Kirti, I would request you to take a snapshot of your code and the circuit and check with the PR department. Okay. Let me just give them an info. Who's over here? Just go to your batch wise and okay. Yeah, Kunal and Sanjay, just check with this guys. Okay, the LED is not glowing. I mean, okay, wait. Kirti and Sai Charan, did you guys have any error in your what do you say coding part? No. Okay, and Kirti, nope. Okay, then just check. Give the this thing screenshot of your circuit to the PR department, and they'll get back with the alternate methods to you. Okay. Respond, or do you want me to unmute yourself? Okay, cool. Moving forward, okay. So yeah, I would say that we are coming to an end of the workshop, but I'm gonna give you a self-study, okay? Why is this a self-study? Because this component is very easy, okay? But this component has a vast domain, okay? You can apply it in a given any number of project, okay? There's a lot of project which I myself have undercome, okay? So that is nothing but LDR. LDR stands for light dependent resistor or photoresistor. Okay, so this is an LDR. Okay, this component, trust me, as this component is used in a lot of, robotics, automation, okay, in solar pan, no, all this kind of things. This has been applicable. I can give you the examples, but this is a self-studies topic. So why am I giving you this as simple? Trust me, because this, when you do it on a self-study, okay, you'll try to find out, you know, get that think of learning, that essence of learning a new thing. So that's the reason I get giving you such a self-study topic. It seems pretty easy, okay, but I will also be the peer department, if possible, will stay back and also give you the coding part, okay. Let me just check this over here. So see, this is a coding part. So this is an LDR, okay, and it needs a resistor, okay. It does require a resistor over here, and this is an LED. You can even use a bulb over here, there's no issues. Okay, once that is done, you can go ahead and you can see over here, right, the LDR is nothing much but a little line. But see, that's what this is, belonging to analog read. Okay, this LDR will use analog read. As you can see over here, A5. Okay, I have all that I have taught you is belonging to these digital pins. Okay, not over here. So get a self study on this, and it will be helpful for you when you move forward. Okay, and yes, that's the end of the module. Well, guys, I would say that this is the very end of the workshop. Thank you for attending the 2-day workshop. I hope this was very useful to you, and I assume that I have done some justice to the teaching of the topics towards you. And yeah, if you have any feedbacks or if you require any other information, please get in touch with Team Vikasana. Just you can find Team Vikasana in Instagram and as well as the mail ID, or you can even stay in the group, and the PRs will give you the contacts of me or anyone else with whom you want to get in contact with. Please check out our page and do keep learning. Okay, as learning is very fun if you take it in a cooler manner. Okay, so yeah, I guess one final rise of fans, and I'll say tata, bye bye.